All right, so we're going to get started with chapter P, section 2. This is going to begin our prerequisite chapter. So every skill that you may be seen in Algebra 1, we're just going to review before we get into chapter 1 of Algebra 2. And we're going to start with exponents and radicals. All right, so you've seen integer exponents before. Now, this is just a way to shorthand repeated multiplication. So for example, if I have a times itself 5 times, that's going to be written as a to the 5th power. If I have something like negative 4 times itself 3 times, that's negative 4 to the 3rd power. And then something like 2x times itself 4 times is going to be 2x to the power of 4. It doesn't matter what the base is, as long as it's the same thing being multiplied by itself however many times, then you can write it in exponential notation. Now, something a little bit more proper would be something like this, right? This is our actual mathematically correct way to say something in exponential notation. So if I have some real number a and I have a positive integer n, then I have something that looks like this: a to the power of n. So I can say it like that, or I can say a to the nth power is the same as a times itself n times. And then we call a the base, and I call n the exponent. Right? And that n is just telling you how many times to multiply a by itself, right? So things that you may be seeing already before. All right. Now, our first rule of exponents that we're going to talk about is multiplying exponential expressions with the same base. If I have something like a to the m times a to the n, that is the same as a to the m plus n. In other words, when the base is the same and you're multiplying, you're going to add the exponents. So something like x to the 3rd times x to the 4th, you are going to add those exponents. So 3 plus 4 to get you 7. All right, and you can think of this like, I'll show you why the rule works. You're not going to write this every single time, but just to show you why the rule works, x to the power of 3 is the same as saying x times x times x, right? That's just times itself 3 times. And x to the 4th is the same as saying x times x times x times x. And so in total, it looks like we're multiplying x by itself 7 times. All right, so then that's going to get us this x to the 7th. All right, now that's the long way to show why it's true. But again, you're not going to write that every single time. I just wanted to show you why it works and why we can just simply add the exponents. All right, and this is the case for anything. Like maybe if I had a number like 2 to the power of 3 times 2 to the power of 5, right? Once again, I can just go ahead and add those exponents. So this is 2 to the 3 plus 5, all right, so 2 to the 8th. And your exponent can be anything as long as the base is the same. So maybe in some homework problems, you see that we threw in some variables. Maybe if I had 2 to the 3 minus p, all right, times 2 to the p plus 2, you're still going to add those exponents. So let's say it was 2 to the 3 minus p plus p plus 2. This p and this p cancel out, and then you're left with 2 to the 3 plus 2, so 2 to the 5th. All right, something like that. All right, if I did have a variable in the final answer, like maybe this was plus w, then it would just be my final answer plus w. All right, I'm allowed to have a variable in the exponent. All right, so let's do some examples, right? This first one, I have b to the 7th times b to the 4th. They have the exact same base, so all I'm going to do is add those exponents. This is just going to get me b to the 11th. All right, when you have numbers in front, like example b, all you're going to do is multiply coefficient with the coefficient. So 3 times 4 is going to get me 12. And then variable with the variable, so x to the 2nd times x to the 3rd is going to get me x to the 5th. Right? Multiplying with the same base, you add the exponents. Same thing with example C, coefficient with the coefficient. Negative 3 times 4 is going to get me negative 12. X times the x to the 2nd and x to the 4th. Multiplying with the same base, you add those exponents. Right? Now, Example D, same thing. Even though you see more variables, it's still the exact same concept, right? So negative 3 times 5, coefficient with the coefficient is going to get me negative 15. All right, a to the third times a, multiplying these two together. If you don't see an exponent, you're going to assume that there is a 1 over it. And then from here, you can apply your same rule, right? A to the third plus 1 is going to be a to the fourth. All right, common mistake that I see, maybe you forget that the exponent's there, and so you just leave it as a to the third. That is not the case. You need to treat this as if there was an imaginary 1 above it, right? And then b times the b to the second and b to the fourth is going to get you b to the sixth. All right. And then if you look at example E, no coefficient, so I'm just going to do variable times the variable. Once again, you don't see an exponent, assume it's a 1. You're multiplying, so I'm going to add. 2 plus 1 is 3. All right, and then n times the n. Treat this as if it had a 1 over it. I'm going to do 1 plus 4, so 5. So n to the fifth. All right, that's all you have to do for that one. And so for example F, again, coefficient with the coefficient. 3 times 4 is 12. Y times y. Add those exponents, it's going to be y to the seventh. Z times z. This is the same as z to the first, so I'm going to go ahead and add those exponents. This is going to get me z to the power of 3. All right. Now, if I had more coefficients, doesn't really make a difference. I can still go ahead and multiply those exponents, right? So another thing to note, if you don't see a coefficient, you can assume that it's 1, right? So if I see a negative with no number, assume it's a negative 1. And I can still do negative 1 times 3 times negative 2. And then if I did negative 1 times 3, that's going to get me a negative 3. And a negative 3 times negative 2 is a positive 6. And then just like before, I can do x times x times x. And that is going to get me x to the second plus 1 plus 3 is going to get me x to the sixth. All right, and then y times y times y. So y to the third plus 2 plus 1 is going to get me y to the sixth. All right. Same thing with example B. Right. Again, if you don't see a number in front, you assume it's 1. So I'm going to do coefficient times coefficient times coefficient. 5 times negative 3 times negative 1 should get me a positive 15. B to the second and b, those are the only two b's there, so these are going to be what I multiply together. This is going to get me b to the fifth. And then a to the second and a to the third is going to get me a to the fifth. This is fine, or alternatively, I typically will write my answer in order of increasing exponent. So something like that. I prefer that over this, but both are correct, right? Because multiplication is commutative. So it doesn't really matter what order you put it in. I do prefer this though. All right. These are the examples where some people tend to get confused. If you look at these two examples, right? So let's look at A. All right, the difference between this first factor and this next one is the placement of that exponent and the placement of those parentheses. In this one, the parentheses are around the entire thing, negative x squared. So that means there's nothing more on the inside of those parentheses that I can do. That side's still going to be negative x squared. Don't have to do anything to it. But this one, my base is this negative x, and my exponent is 2, right? So what does this mean that we have to do? That means we have to do negative x times negative x, right? So that means I'm doing negative 1 times negative 1, x times x, that's going to get me a positive x squared. So I'm going to do negative x squared times x squared, and that's going to get me a negative x to the fourth. Right, so just something to be mindful of. Some people get confused here. If you need to write it out twice for you to be able to understand that this is going to get me a positive x squared, then do that. All right, and if you look at the next one, it has a similar dilemma, although you're going to notice that when the exponent is odd, it does not really matter. All right, so this one, same exact thing. Nothing more I can do on that inside, so this is going to stay negative x to the third. However, my base here is negative x, and that's being raised to the third power. That means I'm doing negative x times negative x times negative x. And if I do a negative times another negative, that's going to get me a negative answer. And if I do x times x times x, that's going to get me x to the power of 3. All right? So that means here I get negative x to the third times negative x to the third. Well, negative times negative is a positive, and x to the third times x to the third is x to the sixth. So I get a positive x to the sixth. Now notice it didn't really matter where the parentheses was. We still got a negative x to the third in both sets of parentheses. As a general rule of thumb, if you have a negative base, right, so I'm going to write on the side, negative base and even exponent, that's going to get me a positive answer. However, if I have a negative base and an odd exponent, that's going to get me a negative answer, right? Just because when you do an even exponent over a negative base, you're going to end up with a negative times a negative, which is a positive. But if I have an odd exponent, you're going to end up multiplying a negative an odd amount of times, which is going to end up with a positive times a negative. All right, and you can work it out no matter which way you do it, it's going to turn out to be the case every single time. All right, so just a general rule of thumb, which might help you down the line, but otherwise you can write it out the way that I did here. All right, now some more expressions to simplify. Right, once the expressions get bigger, do one thing at a time. Do your order of operations. You're going to do multiplication first before you do any addition or subtraction. All right, so let's look here. I'm going to multiply 5 times 2 to get me 10, and x squared and x cubed to get me x to the 5th. Then I'm going to do the same thing on this side here because I'm still multiplying, right? Order of operations. I'm going to do 3 times 4 to get me 12. X and x to the 4th is going to get me x to the 5th. All right, and now there's a plus in between, which now we can take care of because we did our multiplication. All right, now these you actually can combine. If I have the exact same exponent and variable, then all I have to do is add the coefficients. Our coefficients here are 10 and 12, so adding those together is going to get me 22 x to the 5th. All right. Now, something like example B, same exact idea, right? I'm going to do any multiplication and division first before I do addition and subtraction, right? Do your order of operations. So I'm going to do 3 times 5, so 15, a to the 5th and a to the 3rd. Again, multiplying with the same base, I'm going to add those exponents. All right, same thing over here. 6 times, there's nothing to multiply with. I could just write a 1. Doesn't really matter. 6 times 1 is going to get me a 6. And a to the 2nd and a to the 6th is going to get me a to the 8th. Multiplying, you add the exponents. And now I can take care of that minus in between. The a's match, the 8's match. So this is just going to be 15 minus 6. So 9 a to the 8th. All right. So this is just adding, subtracting polynomials, which you guys have done in Algebra 1. Some examples of things that we cannot add or subtract. Let's say this was 15a to the 8th minus 6a to the 5th, right? These exponents are different, so it's just going to stay like this. Another thing that we cannot combine is 15a to the 8th minus 6b to the 8th, because even though those exponents do match, the a's and the b's do not. So this is something that I would also leave alone. So same exact variable, same exact exponent. All right. Another rule that we're going to go over is raising a power to another power. So our rule for this is that if I have a to the m times, a to the m to the n, that is the same as a to the m times n. Similarly, if I have two factors under the same exponent, then that exponent can go to each of my factors. So then I get something like a to the m times b to the m. All right. Now an example here is going to be x to the 4 to the 5th, power to a power. You're going to multiply those powers. Now once again, just to show you that this works, all right, again, you're not going to write this every single time, but I'm just going to show you why it works. Something like x to the 4th to the 5th just means you're multiplying x to the 4th by itself 5 times. So if we do this, if we fully expand it, we're just multiplying a bunch of expressions that have the same base. So what do we do when we're multiplying with the same base? Well, we just learned that we have to add all of these exponents. And when we do that, we get x to the 20th. All right, which gets us the exact same thing as if we were to just multiply 4 times 5. All right. Now, doing some examples. So something like a, I have 2 factors on the inside of my parentheses, and they're both being raised to the 3rd power. That means I can distribute that exponent to each of my factors. So this is going to be 2 to the 3rd, x to the 3rd, and 2 to the 3rd is just 2 times 2 times 2, so 8x to the 3rd. All right. Something like example B is something very similar. It's 2 times x to the 5th. So I'm going to take that 2 and distribute it to both of those factors. So this is going to be 2 to the power of 2 and x to the 5th to the power of 2. And 2 to the power of 2 is just 2 times 2, so 4. And here, a power to a power, I can multiply those powers. This is going to be 4x to the 10th. All right. Next example is going to be something similar, right? I have a negative coefficient this time, but I can treat that as one single factor. So this is going to be negative 2 times x to the 5th. Once again, I can take that exponent, distribute it to each of my factors. So this is going to be negative 2 squared and x to the 5th squared. Right, but negative 2 squared is just negative 2 times negative 2, so positive 4, and x to the 5th squared is still just a power to a power. So 4x to the 10th, same exact thing as example B. All right, but if you look at something like example D, I still have a negative coefficient. All right, this time we have an odd exponent though, right? Remember what I said earlier about the even and odd exponents and the negative bases. You're going to see what happens here. So here I'm going to have a negative 2 to the 3rd, and x to the 4th to the 3rd. Once again, distribute that exponent to each of your factors. Now, negative 2 to the 3rd is the same as negative 2 times negative 2 times negative 2, which is going to get me a negative 8. All right, so negative underneath my parentheses, or underneath my exponent, is just going to get me a negative answer. All right, and then power to a power, you multiply, so it's going to get me x to the 12th. All right, and example E, right, the more variables, it's fine, still the exact same concept. So I'm going to take that exponent and distribute it to each of my factors. So then this is going to get me negative 3 to the 3rd power, x squared to the 3rd power, and y to the 5th to the 3rd power. Negative 3 to the 3rd power is just negative 3 times negative 3 times negative 3, so negative 27. X squared to the 3rd power is power times a power, so I'm going to multiply. Y to the 5th to the 3rd is another power to a power, so I'm going to multiply that as well. X to the 15th. All right, and then this is my final answer. All right, example F. I think there was a typo here, but I'm just going to say, just for the sake of continuing, I'm just going to say that this is an exponent of 2. All right. Now, something like this, you don't see a coefficient. You can either assume it's 1 and treat that as your coefficient, or you can treat negative x as its own factor. All right, that's entirely up to you. I'm going to treat this negative 1 as the coefficient and then do the x and the y separately. So I'm going to take my exponent and distribute it to each of my factors. So it's going to get me negative 1 to the 2nd power, x to the 2nd power, and y squared to the 2nd power. So it's going to get me negative 1 times negative 1, which is just 1. X squared, here I have a power to a power, so multiply, I get y to the 4th. Whether you have a 1 in front or not does not really matter. Right? If you wanted to, you could just write it like that. Right? If 1 is your coefficient, you don't need it. All right, a couple more examples. Again, these are a lot bigger examples. Take it one step at a time. Don't try to do everything all at once. All right, so here I have two things being multiplied, but do your order of operations. Let's work through this exponent first and this exponent before we try to combine things together. Just like before, I can distribute that 3 to each of your factors. So I get 3 to the third power, a squared to the third power, and b to the third power. Distribute that 2 to each of your factors, and you end up with 2 to the second power, a to the third to the second power, and b to the second power. Simplifying all of these, 3 to the third, we've done that before, should get you 27. Power to a power you're going to multiply, this is going to get you a to the 6, and b to the third. 2 squared, that's going to get us 4. A to the third to the second, power to a power you multiply, and b squared you can leave alone. And now this looks like something that we did previously. So you're going to do coefficient with the coefficient, a with the a, b with the b. You guys don't have calculators on your test and quiz, so if you can't do 27 times 4 in your head, do it to the side, just like we did in elementary school, right? Do it the long way. 4 times 7, 28. Carry the 2. 2 times 4 is 8, plus 2 is 10, so 108. A to the 6 times a to the 6, multiplying with the same base, you add your exponents, it's going to be a to the 12th. B to the third times b to the second, again, add your exponents, it's going to be b to the 5th. All right, so we got a nice condensed answer, but again, the original expression was pretty lengthy, just do it one step at a time. Same exact thing with example B. I can take that 4 on the outside and I can distribute that to each of my factors. So it's going to get me 2 to the 4th, x squared to the 4th, and y to the third to the 4th. Same thing with this 2 out front. If you don't see a coefficient, assume it's a 1. So I can say that this is negative 1 to the second, x to the second, y to the second. Or y squared to the second, sorry. And then 2 to the 4th over here is just 2 times itself 4 times, so 16. Power to a power you multiply, I get x to the 8th. Power to a power again, I get y to the 12th. All right, negative 1 squared is just positive 1. Negative 1 times negative 1. X squared, and then y squared squared is going to get me y to the 4th. Power to a power you multiply. And then just like before, coefficient with the coefficient, so I get 16. X with the x should get you x to the 10th. Y with the y is going to get you y to the 16th. Right? Add those exponents and you get this as your final answer. All right? Same exact thing with the next one, just rinse and repeat, same exact process. Do one step at a time. I see that exponent, I'm going to distribute that to each of my factors. So this is going to be 2 to the third, x to the third. Take this 2, distribute it to both of these factors. So it's going to be x squared, y squared. Plus, there's a plus there. Do your order of operations. So it's going to be 4 times, assume that's a negative 1. X squared times x to the third is going to get me an x to the 5th. And there's nothing to combine with the y squared, so I leave it alone. And then over here, on the left side, 2 to the third is going to get me 8. X to the third and x squared is going to get me x to the 5th. And then y squared I leave alone. Plus negative 4x to the 5th, y to the second is just going to be minus 4x to the 5th, y to the second. These are like terms. They have the exact same variables, exact same exponents, so you can combine the coefficients. X minus 4 is going to get me 4. X to the 5th, y to the second. And then to finish this lesson, just doing some special cases. We didn't talk about fractions as your base, but it's the same exact case as if you're multiplying two things underneath the same exponent, right? Just like when you're multiplying and I can distribute that to the factors, I can also distribute it to everything being divided. So I'm going to distribute that exponent everywhere. This is going to become 3 to the power of 3, x to the power of 3, over 2 to the power of 3 y to the power of 3. And 3 to the power of 3 is 27 x to the power of 3. 2 to the power of 3 is going to be 8 y to the power of 3. And that's fully simplified. You can't simplify 27 and 8. If you're ever unsure if you can simplify that, just a helpful tip to know, if you can't simplify this, so 3 over 2, if you can't simplify that, then I can't simplify whatever I raise both of them to, right? If I raise them to the same exponent, then that can't be simplified either. So this 27 over 8 cannot be simplified. All right, some other special cases. Look at examples B and D. Right, so examples B and D have a big difference. It might look really small, but the biggest difference is the parentheses or lack thereof. If you look at example B, think about what your base is. Your base in this case is just this 4. I cannot assume that this negative is attached to that 4. Again, if that confuses you, think of this like -1 times 4 to the second power. And then 4 to the second power is 16, so this is -1 times 16, so -16. But if you look at example D, this entire thing is your base, and it's being raised to the second power. So I'm saying -4 times -4 here, which is +16. If you want to think of it the same way with the -1, right? Let's do -1 times 4 to the second power. I know that I can distribute exponents to each factor. So this is going to be -1 squared times 4 squared. But -1 squared is just +1. So I get 1 times 16, +16. No matter way that you think about it, you're going to get the same answer. All right, so just an important concept for you to understand. All right, same thing with example C. If I had -4 to the third power like this, my 4 is the base, not the -4. So this is the same as -1 times 4 to the third power. So -1 times 4 times 4 times 4. All right, which is going to get me -64. All right, but similarly, think about what we said earlier about negative bases and odd exponents. If I had -4 to the third power, this is the same as -4 times -4 times -4. So I get a negative times a negative, which is a positive, but I have another negative here, which is going to turn back to a negative. All right, so just another thing to be mindful of. And example E, this is just a basic rule from Algebra 1. Hopefully you remember anything to the power of 0 is 1. All right, no matter what the base is, right? So let me give you some other things to think about. What's -4 to the power of 0? Right, this is also 1, right? No matter if this 4 is negative, it is the base of this exponent 0, so it's 1. However, if I had -4 to the 0 like this, just this 4 is the base. So then I'm going to have a 1 from that 4, but I'm still going to have that negative out front. So -1. Again, just some things to be mindful of. They might seem really small, but they change your entire answer. All right, so just things to be careful of, but that wraps up this first lesson.